In question 6, we have a plane inclined at an angle inverse tan 1 over 2 to the horizontal. So here's my plane, here's my horizontal, and in here I have the inverse tan 1 over 2. So let's just set up what the cos and sine of this angle are. Opposite over adjacent, giving root 5 as the hypotenuse. So cos A is 2 over root 5. And sine A is 1 over root 5. A particle is projected up this plane with velocity u. So here's the particle getting projected up with velocity u, meters per second. And this angle in here is theta. The plane of projection is vertical and contains the line of greatest slope, and the particle strikes the plane parallel to the horizontal. So it's coming in parallel to the horizontal, so in like this. So we have alternate angles in here. This angle is going to be the same as this one down here. So when we get the velocities, we can apply them to that angle. So express t, the time of flight, in terms of u and theta. Hence or otherwise establish that tan theta is equal to a third. Okay, if we set up our equations, our accelerations, what we can do our initial, first it's going to be u cos theta in the I direction plus u sine theta in the j direction. My acceleration in the I direction is going to be minus g by the sine of A, we call this angle A here, which is minus g over root 5. And in the j direction, we're going to have minus g by the cos of A, which is minus 2g over root 5. So the time of flight, we use s of y, which is ut plus a half at squared. So u for y is u sine theta times t minus the acceleration 2g over 5. So we'll have the 2 on the bottom, which will cancel with the 2 on the top. So we're going to have minus 2g over root 5. The half, we'll put a 2 here, and then by t squared. So 2's will cancel. Let this equal 0. Factor out our t. We'll end up with u sine theta minus gt squared over root 5 is equal to 0. So my initial time of flight, t is 0, and here we're going to get root 5 u sine theta is equal to gt. I should put a square in there. It's not the first time I've done that. Is equal to gt, so just divide by g, and that will be the time of flight in terms of theta and g and u. So for the landing angle, we need the velocities. So velocity in the x direction is going to be u cos theta, v u plus at. So u is u cos theta. The acceleration is going to be minus g over root 5 times time, which is root 5 u sine theta over g. So v of x at time of impact is u cos theta. The root 5's and the g's cancel, so we're going to get minus u sine theta. And for v of y, we're going to have u sine theta minus the acceleration 2g over 5 times t, which is root 5 u sine theta over g. So the g's cancel, the root 5's cancel, and we're left with u sine theta minus 2u sine theta, which is just minus u sine theta. And we know that the landing angle is equal to the inverse tan of 1 over 2 because of the alternate angles here. So the tan of the angle, tan of the landing angle, call it L, is equal to minus the velocity of y over the velocity of x, and this is equal to 1 over 2. So minus the velocity of y is u sine theta over the velocity of x, which is u cos theta minus u sine theta. This is going to be equal to 1 over 2. Cross multiplying, we're going to get 2u sine theta is equal to u cos theta minus u sine theta. So we're going to get, bringing the u sine theta to the left, we're going to get, we can divide by u again here. So we're going to get 3 sine theta is equal to cos theta. If I divide by cos theta, I'm going to get 3 tan theta is equal to 1. So tan theta is equal to 1 over 3, which is what they were looking for at the beginning of the question. They're also looking for the range here. F of x, ut plus a half at squared. So we're going to have the range being u cos theta times t, which we have from above, root 5 u sine theta over g. And then minus for the acceleration, the 1 over 2, and the acceleration in the x direction, just remind me what it was, minus g over root 5. So g over root 5 and times t squared, which is going to be 5 u squared sine squared theta over g squared. So simplifying this, the g will cancel, and I think that's it. So we need to put in our values for cos theta. We have tan theta. We didn't write cos and sine up here. We have tan theta. So let's, tan theta is 1 over opposite over adjacent. So this will be root 10. So cos theta is 3 over root 10. Sine theta. So we need cos theta and sine theta. So we have u by the cos of theta, which is 3 over root 10, by root 5, u again, so it's u squared, I can see that u there, by sine theta, which is 1 over root 10, and that's over g as well, so the g stays there, minus 1 over 2, so I have the u squared, so I'll just change the 1 to a u squared, and I have 5 sine squared theta on top, 5 by sine squared theta, which is 1 over 10, at the g on the bottom, and the root 5 on the bottom as well. So tidying this up, I'm going to get 3 root 5 u squared over 10g minus 5u squared, just 5u squared, over 20 root 5g. That will simplify to 1 over 4 root 5, and I multiply this one by root 5 over root 5. Let's see what happens. 3 root 5 u squared over 10g minus root 5 u squared over 5, root 5 by root 5, which is 5 by 4, which is 20g. If I make the first one over 20g, it's going to be 6, multiplying top and bottom by 2. It's going to be 6 root 5 u squared over 20g minus 1 root 5 u squared over 20g, which would just give us, if we 6 of them and take away 1 of them, we're going to have 5 root 5 u squared over 20g, which is the same as root 5 u squared over 4. To complete this question, that's the range. I left out my g.